Good afternoon, everyone. My name is Evan Doran, Associate Editor at Modern Machine Shop, and I'll be your moderator today. Today's webinar, Empowering ERP with Machine Data, is presented by Rutherford Wilson, Chief Product Officer at MachineMetrics. His presentation will focus on the benefits of integrating ERP software with MachineMetrics shop floor analytics, from more accurate quoting to optimized production schedules. If you have any questions for our presenter, please use the Q&A box on the right side of your screen. As a reminder, today's webinar is being recorded and will be available for on-demand viewing shortly after today's session. With that, I'll turn it over to Rutherford. Take it away.
Oh, thank you very much, Evan. And welcome to my webinar here for Empowering ERP with Machine Data. So let's go ahead and get started. As Evan mentioned, my name is Rutherford Wilson. I am the Chief Product Officer at MachineMetrics. But just a little bit about myself, which I think is interesting in my role here. One of my first jobs out of college was actually working as a consultant for machine shops. My job was doing, for those of you who remember, TQM, Total Quality Management. It was sort of I wouldn't say a predecessor, but an evolution on the way of lean management. And I learned some very valuable lessons there. You know, for whatever reasons, I was a super geek in college, and I studied Taylor, Taiki Ono, Joseph Duran, and Deming, and I applied all of that knowledge to help customers identify waste and working with operators to identify gaps in processes where we could find efficiencies. And so besides being called college boy for a good part of my tenure doing that job, I learned a lot about how to use data to improve processes. And so while the siren song of startups did call my name, I did spend at least the last 10 years before joining MachineMetrics using machine learning, leveraging big data while working at Amazon. And in particular, I was using that big data and that analysis to help make better financial decisions for people who sell on the Amazon platform and help them make better pricing. So I have a fair amount of experience in using information and real-time information to execute and make processes easier and make better decisions. And that's one of the things I'm going to be talking about with you today, with how we can improve and find efficiencies for your shop floor. So, you know, typically, let's just kind of, most of you know this information already, but let's just kind of walk through a typical manufacturing flow. Obviously, it starts with sales, where you are using either your ERP or your CRM to manage that particular part of your process. And that goes into a planning stage. You then have to, of course, order materials, and then the real fun stuff happens. And there's actually kind of a gap in how the information is tracked from your ERP to this next phase where it hits the shop floor. And so execution is going to be, you know, a number of different things, whether that's, preparing your materials, doing the machining processes associated with making your parts. I can also go into heat treat, paint. And then, of course, you know, we have, if you're using a tool like MachineMetrics, you want to be monitoring all this information through an IoT platform, something that is connected to those machines and delivering that real-time data. But then it kind of goes back out of that world and back into the ERP section where you are tracking your inventory and shipping your products. And that's a typical flow that we see. But, you know, to cross the chasm of these different types of systems, you know, it's usually expressed as a work order from the planning stage. And that work order, in order to cross that chasm, is usually a traveler. It's usually some sort of paper-based form, or maybe you have a digital traveler if you're using that. And then that crosses the chasm back into the other ERP part of the session. And, you know, in this process, there's a lot of extra work that is enabled, that is required, I should say, in order to make sense of this information and to get this information back into a closed loop. Now, of course, with a monitoring system, you know, you want to have the ability to, you know, to track what's actually happening with your machines. You want to be able to auto compute your OEE. You want to be able to track your utilization. And with our software, we give you the opportunity to auto classify downtime. So those reasons, so you don't have to rely on your operators to all the time enter in their downtime reasons. We can identify data from the machine to do that automatically. And the nice thing about when you have all this real-time information, you can view the actual setup times and cycle times and compare that against what was expected. But in order to do that, you need that information coming from your ERP. Now, in addition to that monitoring work that is coming through, you also will have, as part of your execution, some work that is required to happen. You need to record the parts that were produced for each work order, record what's scrap and the reasons for that scrap. And that becomes a really important part of going back into your ERP system. And that, of course, when you do that work and you track that information, that's when you track labor. Now, when you do that work, oftentimes, if you have machines that are running unattended through the night with no operators there, oftentimes the time that is recorded that represents the work that was done is not tracked consistently. It may not represent the actual work that was actually run on those machines. And so that's where you start to have gaps in some of this, in this paper process of managing this flow. And so let's spend a little time kind of talking through the issues that this creates. First of all, if you want to actually integrate your ERP to other parts of your ecosystem, integrating ERPs is complex, and it often is extraordinarily time consuming. It requires a lot of mapping of information from siloed data points that are not often connected together. For example, when you're doing your design work and you're creating your G code for your programs, that information about that program that's running on your machines is not often mapped to the exact part number of as it's described in the ERP. And mapping those work orders to the programs running on the machines, requires manual entry. And it doesn't always work when you are running programs that are on a dual pallet machine or multi-pallet driven machines. And it doesn't always work with machines that are running unattended because there's no one there to kind of draw that connection together. So even though you may have completed your ERP integration, now getting that concept of what work is actually happening and automatically mapping it to the work order that it represents requires human intervention. And when you do have all this data and you do have those humans who are intervening to map that information together, sometimes you have to do it in multiple places. It requires some level of data entry. So you have to map the work in your monitoring software, and again, have to record that information either via labor tickets or however that's done, however that's represented in your ERP. But that information needs to make it back into your ERP system. I know there's a lot of our existing customers that are suffering from some of those pain points. And so that double entry just sort of, it takes some time away, but it's also just annoying. And it creates this additional thing that demotivates your operators for recording this information, which in many cases, at least based on what I've seen, either, my first job when I was doing total quality management and still today, accounting for all of this work, if it's not simple and built into the process in a very easy way, it takes time away from actually making parts. And so planning, of course, is always required. But we all know that you plan to get something done with a set of machines in a certain amount of time with, a set of operators. And in most cases, you have operators that are managing multiple machines. So they're not always in front of the machine that, they're responsible for. They have 3 or 4 machines that they have to operate. When production takes longer than what was planned, or in those rare cases where it actually takes shorter amount of time than expected, that information is not delivered to the right people to make the changes in real time. And that creates a problem where if you're only getting information at the end of the day or at the end of a shift, you can't react to it immediately and update your plan and update your schedule. So in the storyline that I'm trying to describe, Real data really is the spice, and whether you can use the reference from Dune, but it's the valuable piece of information that is helpful to automate some of these processes when you need it, or to make those processes more accurate. For example, if you have the exact part count that's coming from the machine, operator can corroborate the good parts versus bad parts, and then accurately map the time associated with creating that work back into the ERP. So you have an exact representation of how much time was actually spent to create that work from the machine data. Also, add in the time that was associated with the machine was not running. That creates work as well. And so being able to use that information becomes really valuable. Um, it also becomes valuable when you can link the exact parts that were made to the exact work that represents those parts. We create serial numbers dynamically for every part that's made. And when serial number information is passed into our system, we can apply that serial number, and then we can participate in a traceability mode. And so it's more than just being able to take this work away and use real-time data, but this real-time data becomes very important to creating other applications that you need to, depending on your industry, to trace and track what's happening on the shop floor and when parts are being built, and to accurately record that information. So connecting your ERP data with real-time data becomes a very spicy kind of event that creates all this value for you. So let's now kind of walk through what are those benefits of how you can create this value, and what does that mean for creating applications that are beyond what I'm going to be describing today. So the beginning of this, as many of you who've tried an IoT project before, have done any kind of ERP migrations or integrations, the time it takes to get things done with an ERP generally takes longer than you've planned. And so we've sort of tried to figure out a way to understand those dynamics and to do a lot of that pre-work for a large number of the well-known ERPs ahead of time. And so what I'm really discussing here with this slide is being able to simplify the effort, ideally make it as point and shoot as much as possible to build an integration to your ERP and collecting all the data that's required, minimizing the kind of information that a person doing this integration has to enter in. So we've built an integration that simplifies the data that needs to come through. We understand the mappings for a lot of well-known ERPs, and we can map that stuff automatically behind the scenes to represent the right concepts using an ISA 95 normalized data set. And so we can map the machines, the work centers, map them to your cells or the machine groups in our system, and be able to organize that information logically in a defined structure. Our goal for this is to support both cloud and on-prem ERPs, and basically create sort of a wizard-based mapping to link all the appropriate entities from your ERP into the MachineMetrics platform. With this approach, with some of the customers that we've have been beta testing with this, ERPs can be mapped in just really a handful of minutes. And it really takes a lot of that effort and that time that you spend trying to work out all these issues away from building value-added processes on top of this data. Once you have this information mapped, we have a schedule and import process that can either be synced based on a schedule or based on an event-driven process. So really simplifying how data is exchanged back through from the ERP into the monitoring system, and back from the monitoring system back into the ERP. So the goal of this is to really simplify this process, make it clear, make it easy to use. And we've also built in abilities when there's custom mappings that need to happen, those custom mappings can be easily integrated into our system. So focus of this is to make it as simple as possible. It becomes quite easier with cloud-based ERPs. So if you've made that leap to the cloud for your ERP, the approach is really simple to set up your authorization. We have a screen that is, you enter in the authorization code for your ERP. entering the operation code for the MachineMetrics, and using some well-known and very secure protocols, we can enable a secure exchange that is fully fully secure. It's all the data is protected and following the protocols associated with the CMMC2. I can never say this right. CMMC2 level 2 protocols. So your data is always going to be secure as it's being transferred back and through the network. So faster ERP integrations is really just the first step to making this whole combination of services work well together. Now, once you have your ERP integrated, it becomes the next problem is to connect to these concepts. The program that's running on the machine, how does that program link to the part operation or the operations that's in the sequence of the work order? And then how do you link that production run, what's actually running that instance of that operation, to the work order? Well, this is where we had to get really smart. We used a combination of algorithmic logic and machine learning to identify the patterns that are used with the program and identify how we can connect that to your part structure that is coming from your ERP and linking those two concepts together. And when we access the ERP and leverage those and see those exact work orders that are released, we can automatically map the work that's actually running on a machine to a work order automatically. So by mapping that combination of information together, when you have lights out, unattended shifts, a lot of this flow can just happen automatically. And we've created a screen for supervisors where if there is an incorrect mapping, because sometimes machine learning is not always perfect, those corrections can be made in through this supervisor screen where you can make and update those changes. It also makes it a lot easier for us to identify work that's running on a machine that is not planned or scheduled. And I'll get into that in one of the later slides. Now, in this process, automatically mapping everything may not be the flow that your particular manufacturing shop prefers to use. And so we also have made it available for an operator to manually select the work order that they're going to be working on, like they would with a traveler, but it's all now digital. All that information is coming directly from your ERP and being represented identically in the MachineMetrics system so you can select it. And we've made this smarter, so if you have that work order planned to be executed on a particular work asset, it can be filtered to identify what that work is for that day. So all that work can be lined up in order of the execution that is required. Or if you haven't scheduled it to a particular machine, you probably have to schedule it to a set of work centers. And so we can filter the number of release work orders based on a combination of different ideologies to make sure that that information is clear, and it makes it easier when an operator needs to select the work order manually to get to exactly the work that they need to do. We've also enabled this so you can scan in a barcode of that exact work to simplify the process if that's another way to make it work. But connecting all these pieces really makes a clear view of what's happening on the machine and how that gets represented in the work order that have been released. Now, the next power of this is the ability to submit labor tickets. Now, this is a process that people have been doing for decades. And so why change it? Well, I mentioned earlier, sometimes when you have your other multiple systems that are managing your data, having multiple systems that have to have context requires double entry. We want to remove that. So we built our system so the work order could be either selected by MachineMetrics automatically or selected by the operator. Operator finishes their work, and then very easily the operator can just use the MachineMetrics interface to submit the labor that they've completed, being able to adjust to and view the exact data of how many parts were made from the machine data accurately, and adjust it based on how many good parts were made and scrap. And we tie into the reason codes that you have in your ERP to allow operators to select the reasons if they're scrap that was made. They can select the appropriate reasons for each part for scrap or for the group of parts that were scrapped. This becomes really important because it kind of flows into the whole overall process, minimizing the amount of operator input that is needed to complete this part of the work. And so once those labor tickets are synced back up into the ERP, that work can be represented in the ERP at that point in time. Now, we've also designed this so it's bi-directional in every way. So if you are submitting labor tickets to the ERP directly, we can pull that information down and map it to the actual work that it represents. And that's really important for us because we want to make sure we have a clear record of tracing what work was done and how that gets represented to the parts that were made as we track through this real-time data and we monitor your system. That way, if you have scrap that and your quality rate declined, and you can find out what work order that it was done, you can go back to our system and look at all the conditions, the temperature of the setting, the temperature of the machine, the settings of the machine. You can look through all that historical data to find out why that scrap was created. And so it's not just about reducing the amount of double entry, but it's also tying these concepts together so you can actually track what was actually happening at the machine when these parts were created. This becomes especially important when you want to compare if you have a scrap rate that was higher on first shift than second shift, you can look and see what was actually happening on those machines to see what those differences are. And that is really good information to help you improve processes, identify where efficiencies are being introduced into the process, and then that gives you a way to take steps to improve them. Now, the thing that I'm most excited about that I think is going to be really interesting when you have connected all this information is once you have your work orders in place, you've connected it to the operating real-time data that's being monitored from the machines, this creates a live view of your production schedule. So, part counts can be incremented as they're being made. So every 30 seconds or every 5 minutes or every 2 hours, depending on your cycle times. And you can see the trajectory of how those parts are being made and track them in real time for each work order. So it gives you that live view. And because we understand the work order, we understand when parts are being made, and we understand all the data associated with creating that part, we can identify, what was the planned time, using the expected cycle time, and then what the deviation is with the actual cycle time. We can see the history of downtime for this particular machine and the history of downtime for this machine connected with making this part for this particular shift and predict how much downtime is going to be made for making this new part. So we can get a very accurate understanding of how long it's going to take to actually make this part, which may be different than what was scheduled. And so, and because this is real time, we've designed our algorithm to react with real time information. So if for some reason a tool breaks, the machine goes down, that's something that is unplanned. It's a new event. It's a new anomaly. Well, that information, the average time it takes to fix a tool, to change a tool, can be incorporated in this algorithm and then re-estimate how much time it's going to take to complete. We sort of call this sort of like Google Maps for on-time delivery. Being able to estimate when things are going to be done, basically what time you're going to arrive, and give you that information in real time and update it when things happen that were unknown or unplanned. So that's a very powerful feature, and because this is all live information, the right people, your production scheduler, your shop floor manager, they all have access to this information immediately. And that's a big change. That's a huge value point associated with doing all this work to connect all this information together in real time. I said real time is the spice, and it makes it really important. Now, because we have this live view of what's actually happening and how long things are actually going to take based on our algorithms, obviously you have the ability now to make better production planning changes, and you can do those changes faster. But it also gives you a view if things are actually being produced faster than you expected. It gives you a view of unused capacity. And that unused capacity is easy to see at a glance. We've actually built in the full version of this, we've built in some calculations so we can identify where there's unused capacity, even based on the additional work that's coming up next. Because we now, since we have access to all the work orders, depending on how you plan them out. If you plan them to an individual machine, we can see the work that's scheduled for each individual machine, and we can see the next series of work that's planned for each individual machine. And so if there's unused capacity that's available even after a series of work, we can identify when that's going to be. So when you connect all of these pieces together, not only do you get other abilities to simplify how your work is being recorded, to get visibility into your production data, this information can all be pushed back into your ERP that helps you quote better. If work is taking longer than you expected, you can update how you're quoting for it so you can realize optimize your margins associated with producing that part. If work is actually being executed faster, you may want to be more competitive and be able to have clear data that represents how you can lower your prices to your customers to be more competitive in the marketplace. But the key about this is having this information and having a way to close that loop from the planning stage from the quoting stage, the planning stage, through the execution stage, and having all that information back into your process. So when I started at MachineMetrics, and when I got to MachineMetrics, a lot of MachineMetrics was focused on giving you the metrics, and very good metrics, baseline information. We gave you actual cycle times versus your expected cycle times. We gave you the baseline information so you can see over the last 6 months, are you improving or not improving in terms of utilization or in terms of your OEE. But my view is, if we can give you tools where as part of your everyday work, so in the process of making parts, in the process of recording your information, being able to use that work to generate even better information associated with how you can improve, then that becomes a win-win. It becomes a win for our customers who are using our products because now they have enhanced visibility in their operations. It also becomes a win for your operators because now they have more data in real time to see how well they're doing. So at the end of the day, empowering your ERP with this machine data becomes a huge benefit. And while I've identified 2 key tools, the labor ticket application and the production schedule application, there's a lot of information that you can use this information to help improve your operations. As I said, real-time data is the spice. While not directly connected to the ERP data, real-time data in identifying when a tool has broken is a fascinating asset to help your operators reduce their downtime. Several of our customers who we've prototyped this tool break alert system with, sometimes they don't know when a tool is broken, and machine continues making scrap. And with this system, with using this real-time data, there are other applications like identifying when a tool is broken, when there's an anomaly in the load associated with the tool. We can pull that information and tell you about it. And when that data becomes consistent across your entire set of shops, we can even stop the machine from making continued scrap. So real-time data is truly the spice that can really help elevate your digital transformation and help make you more competitive in the market. So it's a short presentation today, but I hope this is helpful. And if there's any questions, I'd love to field them now.
All right, thank you, Rutherford. We will now transition to our Q&A period. Again, if anyone has any questions, please use the Q&A box on the right side of your screen to submit questions. And with that, we'll get underway. So can you say a little bit about what specific ERPs you currently support, stuff you have built-in integration compatibility with?
Yes. So as I showed on the screen, we have support for JobBoss Squared. It's a cloud-based ERP. Epicor Kinetic, another cloud-based ERP. Visual. It's an on-prem ERP. And we are wrapping up integration we have one-way integration with ProShop, and we're working with them to integrate a bidirectional communication. We started evaluating integration with SAP, but that is currently not in place.
Sure. And then does this system support a homegrown ERP or MES system?
That's one of the key design requirements of our system. In order to make it as simple as possible to integrate an ERP, we spent a lot of time designing our APIs. So they are focused on the key concepts that need to be applied. So while we are not, if you have a homegrown ERP that has some of the key objects like a work order, sequences, a master operation table, we'll be able to use our structure to easily map to a homegrown ERP as well.
Sure. And then does the machine data always represent what's been going on? Like, for example, if you rework a part, would the system know that you've done rework and not made another part?
We're still working on that piece. When we rework a part, we can identify that as a part operation, but we don't always identify that as a rework. So that's something that we're still working on, but we're getting closer at being able to automatically identify when a part's been reworked.
Sure. And then for someone who's already using labor tickets in their ERP, what are some benefits of MachineMetrics that would make it a good idea to switch?
Yeah, so I alluded to some of those pieces already, but depending on so first of all, one aspect of it is if you are entering your labor tickets into your ERP through the ERP interface, we can absorb that information and still map it to the activities that are directly related to the work and the parts that were created. But one of the things you don't get when you do that is we've seen dozens of our customers who are doing this process, and because a human is typically involved in recording their labor tickets and recording the time, they get inconsistency associated with the actual parts that the machine made and the actual time associated with the work to making those parts. And so when you use real-time data associated with what was required to make those parts, we can either backdate the information or record that information and link that data together. So you can see, in many cases, you can see, at least in our system, the delta from the labor that was required versus the machining time that's required. And so it gives you a richer set of information that is not always available when you're just strictly submitting that information to your ERPs.
Sure. Now we have another question hoping for a bit of a clarification. How do you define real-time data for MachineMetrics?
That's a really good question. I always, being in an actual real-time world in other industries that I've been in, the use of real-time can be used in ways that it probably shouldn't be. So in particular, what I mean by real-time data, it's information, the cadence of the data that we submit back to our user interfaces is usually about once every 3 to 6 seconds, depending on network capabilities. And so you get update of information every 3 seconds, roughly.
Sure. And then we have another question along a different track. How are scrap reasons recorded and tracked?
Yeah, so there's a couple different ways that scrap reasons can be entered into our system. So first of all, we have an interface in the MachineMetrics platform where you can enter in your scrap and your scrap reason codes. And then when an operator or selects a number of different scrap items, they can also select the reason code. They can select the reason code. And if there's, let's say there's 6 items that were scrapped, they can actually apply the number of scrap items to each reason code. And so that's one way to do it. The way that when we are integrating directly with the ERP, if you have scrap reason codes in your ERP, we built our module to pull that information down from your ERP So when we submit the labor tickets, that information can be immediately tracked and synced back up identically to the ERP. So the scrap reason codes can be entered into our system, or they can be pulled from the ERP and linked and synced back and forth.
Sure, and I guess kind of going along with that, um, if a machine is like, if it goes ahead and it communicates that there's downtime, um, how does it know if the operator is inspecting parts during that time or looking for something, or if the operator's kind of just goofing off?
You have operators that goof off? No. Um, there's two ways to do this. So um, downtime so let me speak a little bit about our auto classification of downtime. Um, we have a customer, just to give you the outcome before I talk about the reasons and how that happens. We have one customer that has a bunch of Swiss machines, I think around 85 Swiss machines, and using our algorithms that they've structured, about something around, I think we're up to about 82% of their downtime is accurately being classified by our heuristics that we put in place. Um, Other customers that have a more varied set of machines, which means they have a number of other possible reasons why they might be down. They're achieving sort of like a 60, in the high 50s, 60% range of downtime. So we won't be able to identify everything. But how we do it is we use data from the machine, alarm data. For example, if there's a fault in the machine, or if there's a signal that says that the door has been opened, the cabinet has been opened, or operator not available because there's a point where there's operator input needed, we can identify and classify that information through that data. And what we've designed is a back-end system that can run and check for all these different points, whether it's alarm data or a combination of events in the machining of the system that make it clear that when there's idle time, we can classify it. And we've designed a front end interface. It's fairly rudimentary right now, where you can actually map these different events to these reason codes. So when we can't understand why there's downtime is when the operator is goofing off. We don't have an IoT device attached to an operator. Don't think that's something we ever want to do, but we use it using machine information that signals good reasons, and it's configurable by customers. So it's something that can be customized to each shop and how they work to organize that. And so it's not perfect. It can't classify everything automatically, but it won't be able to identify when an operator is goofing off.
Sure, and then do you find that the ERP integration, how does it work in a high mix, low volume environment?
Oh, high mix, low volume is awesome. It's actually really, really well designed for that. What happens? So actually, let me answer this in two different ways. In a high mix, low volume world where you are um, issuing a number of different work orders, um, it's that key. The work order is usually the key component that is tracking this work, and you may be only doing like 5 or 6 parts for a single job, and you have to track that information. And so if your hygiene of your ERP is very clear and the data can be mapped all the way through, then it becomes a very key way of reducing time, because you don't have to spend a lot of effort to manage the accounting of a lot of these work orders that may be coming through. Sorry, that's high mix and low volume. And so it helps that process quite significantly. Where this approach that we're taking can be a little different is sort of the reverse of that. High volume, low mix, where you're not necessarily using work orders to drive your work. And that's where we have a couple of customers that definitely exist in that world. And a lot of the time they're building the stocks. They just keep running the same part over and over and over again without the trigger of a work order. We still operate well into that, but right now we've designed it to kind of key off that work order and map those issues together. So even in the high volume, low mix, work orders, as long as work orders are being generated to represent work, we can track that information.
Sure. And then how do you connect different brands and different types of machines to the system?
That's sort of the core of where machines started. We have built a significant number of custom adapters, which we improve all the time, to speak to Akumas, to speak to Makinos, to speak to Fanucs, Siemens, Citizens, and each information, each machine will have a different way of tracking their information. And so the heart of the ability, once we connect it to this data, we have an auto normalization system that learns from previous mappings of how we've taken data from various different systems, identifies those commonalities, and then maps it automatically. We're actually just about to release a batch connectivity set where not only so currently when you connect a machine, you connect the machine one by one, but since we have all this I wouldn't quite call it machine learning, but just very intelligent algorithms that can learn new connections and new devices and remember them, so it can automate it for the next time we do that. So what we are designing now is a way to take the name of your machine, whatever you want to call your machine, your IP address. We automatically scan your machines based on the IP address, determine what type of controller is available, run updates on the controller if it's not at the latest version, and then can connect all those machines in a batch. You get a couple of opportunities to review what decisions we've made. So if we see there's a machine that is connected to with MT Connect or OPC UA or with a FANUC focused controller, we can identify those, check the versions, update that, and we review that with you before we take actions. Then all you got to do is hit connect, and then we create a series of asynchronous services that can connect all. And we can connect 100 machines in about the span of about 2 minutes.
Sure. And we've got about one question left. If anyone has any other questions to ask Rutherford, please, again, feel free to use the Q&A box. But how do you ensure that an operator records downtime? Like, can a job be continued without entering the downtime reason? Would it automatically report something?
It's a very good question. We have a configuration in our system that can either be enabled or disabled. When we identify downtime, and downtime, we will flag the operator through their laptop or through the tablet that we have in front of the operator at that machine. That alert can either be persistent, so you can't do any other activities on that laptop or that machine until it's answered, and that can be a configuration that you can set, or it can show up and go away after a certain amount of time. It can also be configured about what is classified as downtime. So maybe if you're down for a micro downtime, like every a minute or maybe 30 seconds, you don't want to alert the operator to record downtimes. So it's a configuration that you can enable to it's hard to say force the operator to do something, but to alert the operator and be annoying or less annoying in order to get them to implement downtime. Because some people have tried to do that, I just wanted to share some lessons learned. Getting operators to enter in downtime, it's very difficult for a system to enforce that behavior because it is a cultural thing, usually with a shop floor. If they see value in doing it and get information back from that system, more operators are more prone to entering this information. But in case that doesn't happen, or if it doesn't happen in real time, we've also built a batch-based downtime entry system. And many of our customers have actually kind of moved away from the operator entering downtime and the cell manager or the person kind of supervising the cell we'll be able to go into our batch operating system, our batch downtime classification system, and be able to look at a number of different systems and categorize them in groups. So it makes it a lot easier instead of doing it in a one-by-one basis in real time, or at least in the moment of making parts. So there's a way that you can do it asynchronously to the making of a part and still get the same outcomes out of that.
Sure, and we had another question come in. Can you describe the connection between Epicor and MachineMetrics? Like, do you need the machine MES module in Epicor to use MachineMetrics? Does MachineMetrics replace that?
You do not need the MES module with Epicor in order to get that connection working. We are using the APIs, the Epicor open APIs, to speak directly to the Epicor system.
All right, and I believe that takes us to the end of our questions right now. If anyone has further questions or wants to learn more, feel free to contact MachineMetrics directly for assistance. Thank you again to Rutherford for presenting today. As a reminder, today's presentation has been recorded and will be available for on-demand viewing shortly after we conclude. With that, thank you to everyone for taking the time out of your week to listen to us, and have a great rest of your week and a great weekend.